Question 14, Part D. A particle is projected from the origin with initial speed v at an angle of theta to the horizontal. The position vector of the particle, vector r of t, where t is the time after projection and g is the acceleration due to gravity, is given by vector r of t equals vt cos theta for the horizontal component and vt sin theta minus gt squared over 2 for the vertical component. Do not prove this. Let d of t be the distance of the particle from the origin at time t, so d of t equals the magnitude of vector r of t. Show that for theta less than inverse sine of the square root of 8 over 9, the distance d of t is increasing for all t greater than 0. By Pythagoras' theorem, the square of the distance, so d squared, is given by the sum of the squares of the vertical and horizontal components of the vector r of t. So d squared is equal to vt cos theta in brackets squared, so that's the horizontal component squared, plus vt sin theta minus gt squared over 2 in brackets squared, so that's the vertical component squared. Applying perfect square expansion to both of the terms in brackets there, we get d squared is equal to v squared t squared cos squared theta plus v squared t squared sin squared theta minus 2 times vt sin theta times gt squared over 2 plus gt squared over 2 in brackets to the power of 2. Factorising out v squared t squared from this term and expanding the brackets here and here, we get d squared is equal to v squared t squared times open bracket cos squared theta plus sin squared theta close bracket minus vgt cubed sin theta plus g squared t to the power of 4 over 4. Now cos squared theta plus sin squared theta is the Pythagorean trigonometric identity equal to 1. So d squared simplifies to v squared t squared minus vgt cubed sin theta plus g squared t to the power of 4 over 4. Now d represents a distance, which means it can't be negative. And since the distance d is greater than or equal to 0, if d squared, in other words, this expression here, is monotonic increasing, then d itself is also monotonic increasing. So what we can do is to show that the derivative with respect to t of d squared is greater than 0. And if that's the case, then d itself, the rate of change of the distance with respect to time, is also going to be greater than 0 for all t greater than 0. So differentiating d squared, so that's this expression here, with respect to t, we get 2v squared t minus 3vgt squared sin theta plus g squared t to the power of 3. And we can factorise out t from all three terms, and that gives us t times open bracket 2v squared minus 3vgt sin theta plus g squared t squared close bracket. Notice what we have in the brackets. We have a quadratic expression in the variable t, and if we read it backwards, it would be g squared t squared minus 3v gt sin theta plus 2v squared. This would be the constant term of this quadratic expression. And this term here would be the middle term. Now we know that t itself is greater than 0. So what we need to show is that the quadratic expression here is positive for all values of t. And the only way that that's possible is if the discriminant of this quadratic expression is negative. If we were to graph this quadratic expression, it would be a concave up parabola, but we want the parabola to be totally above the x-axis or the horizontal axis. And that happens when the discriminant delta is negative. So d dt of d squared is greater than 0 if the discriminant delta of g squared t squared minus 3vg sin theta in brackets times t plus 2v squared is negative for all values of t greater than 0. So we want to solve the inequality delta less than 0. Now delta is b squared minus 4ac. So that's the component that's inside the surd of the quadratic formula. And using this quadratic expression here, this is our b squared. So 9v squared g squared sine squared theta minus 4ac. So minus 4 times g squared times 2v squared less than 0. So multiplying these terms here together, we get the inequality 9v squared g squared sine squared theta minus 8v squared g squared less than 0. Now we can divide all terms by v squared g squared since v squared g squared does not equal 0. So it won't have a division by 0 error. So the inequality simplifies to 9 squared theta minus 8 less than 0. And rearranging the inequality to isolate sine squared theta, we get sine squared theta less than 8 over 9. Now, since the angle of projection theta is greater than or equal to 0 and less than or equal to pi over 2, that means the value of sine theta itself is positive. So taking the square root of both sides of this inequality, we get sine theta is less than the square root of 8 over 9. And taking the inverse sine of both sides, we get theta is less than inverse sine of the square root of 8 over 9. Therefore, d of t is increasing for t greater than 0, given that theta is a value less than inverse sine of the square root of 8 over 9.